So today now we shall start with Kubeadm setup. Means we'll create some virtual machines and we'll create the cluster with Kubeadm, right? So let's proceed and create a cluster. Any questions here? So let us go to our AWS. Here we shall use, first we shall create some new VMs and assume that they are just standalone servers, and we'll create the cluster. We'll not use any service for the cluster setup now. I'm creating a cluster with two nodes. So one would be acting as master, the other one as a worker node. Remaining all are same. Use the keypad and launch the instances. Okay, let's go and connect with this. This one is going to be the master node. Just let me name it. Which one I took? The IP address of this. Okay. Let me name it as Kubernetes master for our identification. Okay. The second one is the Kubernetes node. Right, let's go to the master. Okay, this is the master node. This is going to be a master node, and this one is the worker. Okay, so now, yeah, two nodes are ready. So before creating a cluster, we have to do some pre-configurations here. Here you can see some host name, right? Some DNS name, the default ones we are seeing. I just want to change their host names as master node and worker node. It's not mandatory, but a good practice, okay? I'm just changing the host name. How do you change the host name? With a Linux command called hostnamectl set host name. I'm setting this host name as master node. And this one also as worker node 1. Okay, and then these servers should resolve their host names with each other. So go to etc host file. There is a file called etc host. Here place those entries, the IP address and the host name. Okay, let's go here. The IP address I'm using the private IP and the host name is master node, and then get the worker IP. Okay. Yeah, these changes should be applied on the worker node as well. Let's go to the worker node. They should resolve their host names with each other. So put these entries on the worker node as well. So yeah, we have placed those entries in the host file. We have changed the host name. For those configurations to apply, we can reboot. And also one more thing, for them to connect, we have to disable security in Linux. There is something called SC Linux. Okay, we need to disable this for them to communicate. How do you disable security in Linux systems? Set enforce to 0. Right, see, SC Linux is disabled. Do the same on the worker node as well. Right, so fine. Now restart our system so that we should see the applications, like the we should see the applied changes, right? Like the host name should be changed. Let's wait, restart the session. Okay, so EC2 user sudo SC. Can you see the prompt here? The host name got changed to master. So let us do here also. Let's log in. Okay, you can see here worker node. Okay, the host names were set. Everything is fine. Okay, now let us install Kubernetes. So how do you install Kubernetes? You cannot directly install with yum because Kubernetes repositories are not available in the, Kubernetes repositories are not added in the yum repos. You can check that here. Go to, I have shown you in the beginning when we install Jenkins. Right here, if you see, there is no Kubernetes repository added by default. Okay, we shall create a Kubernetes repo file. Okay, with the URLs, with the links from where this Kubernetes should be downloaded. By default, it's not available. So I'm running this command. Can you see that? Cat till the end of the file into this. Means create a file called Kubernetes repo in this path. Okay, and this Kubernetes repo should have this content, right? It should be downloading Kubernetes from these references, from these URLs. This is a base URL. So do the same for the other machine also. Just go here. Okay, done. Here also Kubernetes repo file should have been created. Done. So now I have added this Kubernetes repositories to yum package manager. We can install them with yum. Okay, I'm installing here 3 packages. Kubelet, okay, Docker and Kubeadm. Let me run the command. And also particular version I'm installing. What are all those we are installing, I'll tell you. See here. Okay, let it finish. See, this is the command. So what are we installing? Docker. Like I said, Docker should be running on every Kubernetes node. So Docker is installed. Kubelet. We learned what Kubelet does. API component interacts with the Kubelet. Kubelet is the main component which runs on every node. So Kubelet and Kubeadm. Kubeadm is a utility with which you create your cluster, with which you manage your clusters, creating, deleting your clusters, getting information of the cluster. All that is done through Kubeadm. It's a tool. So we are installing it. And then kubectl. Kubectl is nothing but Kubernetes command line utility. This is very important component. Kubectl, okay. Kubernetes command line utility. This is helpful to give instructions to the cluster to interact with the cluster. You may be setting up the cluster with Kubeadm or using GKE or EKs. You may use any services on cloud. You may use any method, but still you need kubectl on every cluster, because kubectl, like I said, you will be interacting, giving instructions to the cluster with kubectl. So this should be installed on every kind of setup. This is important component. So yeah, we have installed all of them. Right now, let's start Kubelet and let's start Docker. Systemctl start Docker and start Kubelet. Okay, enable Docker and Kubelet as well. Right? So done. Kubelet is running, Docker is running, everything is all set. Now let us start the cluster. From the master node, you have to start the cluster. So how do you start the cluster? Yeah, there is a command called kubeinit. Let me show you the command before running it. Yeah, can you see here? This is the command kubeadm init API server advertise IP address, the IP address of the master, pod network CIDR block. If default pod network CIDR block means pod network range. Okay, pod IP address will be within this range. That's the default pod network range. And then ignore pre-flight errors. See, to create a Kubernetes cluster, there are some prerequisites. Every node should have two CPU cores and 2 gigs of memory. Okay, but when you check out our instances, which we have created, these are T2.micro instances, which will have only 1 CPU core and 1 gigs of memory. Okay, but prerequisite is 2 CPUs and 2 gigs of memory. But for our practice, for our learning, this is enough. So I have created this way. So it will show you some error. So ignore the errors regarding CPUs and ignore the errors regarding memory. This is what you should do. This is the command to start the cluster. So let's put the master IP address here. Put the master IP. Okay, let's run this command. From the master node, we should run this command. Okay, it will take some time to bootstrap the server. Meanwhile, let me tell you. So yeah, for our learning purpose, these T2.micro instances are fine. Okay, but like I said, some of the advanced features we cannot see with this kind of a setup. We'll go for EKs. And also, not only that, when we talk about Helm is another concept. So Helm also, these T2.micro instances will not be sufficient. Then we shall be creating again cluster with T2.medium or T2.small. T2.medium would be apt. T2.medium instances. Okay, they will be charged. They are not free, but a very minimal amount. We can create the cluster with those instances when we are going to start help. Until then, this cluster will be fine. If you want, you can create now only a big cluster, or else when you go to that concept, we can create it. So on master node, yes. Do you see that your Kubernetes control plane, your master is successfully created and it is giving you some key, some token. Like in the case of Swarm, this token should be running on, you should run that on the nodes, whichever you want to act as a worker nodes, Kubernetes worker nodes. Okay, meanwhile it is added. Let me show you. See here it says cluster is started, and to start using your cluster you need to run the following commands. Okay, make directory. See, because we have created a cluster as root user. Okay, always you may not be having root user privileges of your cluster. You may be having only, you may be given only a regular user privileges. In that case, this is how you can give permissions to regular user. First create a directory. Sorry, you should be running them as a regular user. I want to run them as EC2 user. Okay. Sudo copy. Okay. Copy this admin.conf to a directory called kubeconfig. What is this kubeconfig? We'll discuss as we progress. We are having concepts related to it. For now, just put the admin.conf in the kubeconfig directory of that particular home directory of the user. So done. Once this is done, I should be able to connect to the cluster as EC2 user. So how do you connect to the cluster? Like I said, Kubernetes command line iterative kubectl get nodes. Yeah. Do you see master node, worker node? Two nodes were available in the cluster. And by the time if you come here, yes, it says that it is added to the cluster. Okay, so now cluster is almost ready. But for them to communicate, we need to install some network plugins. Okay, there are so many network plugins like Flannel, Calico and all. Already those manifest files are available. Just run those manifest files. These are officially available, like official documentation available for them. Just apply them. You will see the meaning of apply command, kubectl apply the YAML file. As we progress, just install those plugins. So it's almost ready. You can check now with the kubectl get nodes. Okay, so cluster is ready. In few minutes, the status should become ready. Okay, worker node is ready. Master will also get ready in few minutes. Let's wait. So yeah, that's how you create a cluster. Any questions in this part from anyone? So this cluster setup, do it carefully by following the document. You have the document in the drive. Follow the document and do the setup carefully. That's what you should do. Yes, do you see here? Master node ready, worker node is also ready. So yes, our cluster is ready. Now if you want to see whether we have any pods, see, no pods. Do we have any services? What are services? What are pods? All of them will see that's a default service. And we have so many objects to be created. Deployment objects, pod objects, services. Okay, you will be also creating something like daemon sets, stateful sets, and so on and so many. Get all. right? Get all will show you all the components. Only service or default service is available, right? So these are there are different objects in the Kubernetes API, different REST objects like pod object, service object, deployment object, okay, stateful sets, daemon sets, okay, persistent volumes, persistent volume claims, and volume claims, yeah. And again, different service types inside the service. Under this service, you have different types of services like node port service, load balancer service, and node port load balancer, yeah, cluster IP service, headless service, and so on.